Hi, I'm Siddhant. I work in Razorpay as a developer experience engineer. So our job is to help Razorpay developers or external developers who are working in Razorpay their lives easier. So as part of that, I work on the documentation where we are working on revamping it. So I'm just going to talk about our experience and our journey so far. Yeah, so a little bit of a background about the documentation side. So this was first launched in 2015, and it basically covers content around all the products that Razorpay has. It just gives a brief and details both around the products. And the second part to it is explaining the APIs. So whatever APIs Razorpay supports, our documentation basically gives information around that. Um, so as I mentioned, this was built in 2015 first, and while it has gone through a couple of iterations, there were certain problems that we noticed with our website. So first and foremost was the build system that we were using was quite unreliable. What that meant was we were seeing a lot of production issues, ranging from, let's say, the content is broken, or whatever links we have given, they might not work or may work. So that was a really big problem that we faced. Another thing that we faced was around customer satisfaction. Our developers were, the developers who were using the documentation had quite a few times pointed out various pain points that they suffered. Um, Third was around the internal developer experience. We know that internal developer experience is really good, really important for fixing bugs early or keeping developers happy in general. So again, being an old system, this was a little subpar for us. And finally, last but not the least, so we have a tech writers team who actually manage the content. Whatever content we see on documentation is managed by that team, and their experience and their processes were completely broken. There were a lot of issues which hindered the speed and reliability with which they could generate new content. Sorry. So yeah, given these issues, we decided that we need to do something about it, and we wanted to move to a new system. We targeted three main aspects with this move. One was the first one and the foremost one was to improve our users' experience and the quality of content that our documentation can give them. The second was to improve the tech writing or content writing processes, so that again this ties with the first point as well, that uh, if we can make the processes faster, the content that our users will get will be much better. And lastly, we wanted to improve our own developer experience. So we didn't want to wake up at 1 a.m. To see some content is broken or wrongly rendered. So I won't be going into much detail about the old new system, but this is just a overview. In the old system, we were using jQuery, and while it is great, we wanted to move to React so that both the developers' experience as well as their speed could be increased. As for the content, our content is written in Markdown, and we were using a library called Markdown.net to basically convert the Markdown into HTML. Instead of that library, we wanted to something called MDX, which we'll look into it a bit later. So moving to a new system or migrating to a new system is always a big task. The current system can have a lot of nuances, and you don't exactly understand always where there can be things that can break. So we wanted to take the migration in multiple phases so that we can ensure that our website is up and we don't take too much at once. So with that philosophy, we divided the move in three phases. The first phase was to replace jQuery and our previous system with the React-based system. The second one was to update our parsers. So as I mentioned, we were using something called Markdown.net, we wanted to move to something called MDX, which will help us parse our Markdown content reliably into HTML. And finally, we wanted to make our docs much more interactive. So if you see our previous docs, they seem like a normal HTML based website. They don't really have much interactivity. So that is a big push that we wanted to make, which will eventually improve our users' experience. Cool. So since we divided the move itself in 3 phases, this talk will just cover the first phase, where we'll talk about how we moved to a React-based system. So for us to move to a React-based system, there were 2 parts that we needed to solve. First was how do we render a Markdown file in React, and the second one was how do we take all the content files and render them in our website. So the challenge here for us was that we have more than 1300 pages in our documentation website, and we wanted to figure out the best way to render it in a React-based website. So let's start with the first point, like how do we render Markdown? So for this, we initially came up with 2 options. Option 1 was to just import Markdown into our component, convert that to HTML, and just render it. So if you look at the code here, this is just pseudocode. We are importing the Markdown from a content file. Then we are using our Markdown based parser to convert it into content, and then we are basically setting it as basically injecting it into our React tree. So that was our first option. This would allow us to continue using whatever plugins or whatever extra custom components that we already support. It'll allow us to continue using them while we change our underlying system. Another option that we considered was to generate this HTML beforehand and just pass it to a dummy component which will just render it. So in option 1, we identified a couple of issues. First was if we are going to create a component for each of this content file, doing it manually is not something that we wanted to do, given that we had 1300 pages. So that was one issue with option 1. And the second issue was that the content parsers that we have, those were basically not client safe. What I mean by that is they were written for the server, and they were written in such a way that they will run on a server itself. Now, if we were to run this on the client, that would cause our website to break. So given these 2 issues, we just wanted to quickly move on with the POC. So we went ahead with the option 2. So now that we have figured out how to render a Markdown, the second part is something that we wanted to tackle, which is how do we create all the routes for our website. So again, here we had 3 options. Option 1 was to write it manually. So writing 1300 content components manually was something we didn't want to do, definitely. So then there was another option where we thought that since our tech writers already manage the content, they can also help us by managing a config file, which will have all the routes that are required to be rendered. While this seems like a better solution, there were a couple of issues with this. One was that maintaining another separate file would mean that we have 2 sources of truth. One is the content itself, and the second is a config file. And keeping this content file, this config file, and all the content in sync is something which is going to be very difficult and is very error prone. And building on an error prone thing, if we are asking tech writers to write a config file by hand, there will most likely be typos in the way they define the routes. So given this, we wanted to move to a more automated system, which was our option 3, where we thought if this config file is basically dependent on the content, why not just generate it ourselves? So that is what we did. We basically relied on the file system. The way the content was written, the way the content was nested, is how it will show up on the website. So given that, we basically came up with 3 steps, a three-step procedure which will basically create a route config for us. So number one, basically go through all the content, figure out all the files that are there. Now for each file, based on its nested path, we are going to generate a path where it will be rendered on our website. Once we have this path ready, what we do is from the content file, we read all the Markdown content. We already have our Markdown based parsers that we talked about earlier. We use them, generate HTML, and we return that to as a route object. I think code will be much better here. So let me just quickly show some code. Yeah. So as you can see, we basically read all the files. For each file, we get the path where we want to render it. We read the Markdown, we converted it to HTML, and we just return it as a route object. Now, I'm very glad that Pulkit went ahead of me because he was able to explain the different rendering mechanisms. So we were basically using one of those, which is called SSG. So we took this route config, we inputted that into our SSG system. Voila, our website started working. So we were really happy at this point that our POC was successful, or so we thought. So after running this website, we basically stepped into some issues. I'm going to ask one of you folks, or any one of you folks, if you can notice something here. Any issue that you might have noticed. Yeah. So I got size of the bundle, which is exactly correct. So if you see closely, we are transferring close to, more than 3 MB of data just for a single bundle, and this is just a condensed. Okay. Okay, sorry about that. We are just, so the main bundle itself is 3.3 MB, and that's gzipped. So this was a big problem for us. We had a huge bundle size, and as I mentioned multiple times, we had 1300 pages, and at this scale, this was just unusable. And this is how we felt. Right, so we thought, okay, let's go about debugging it. So this is just a snapshot from a tool called Bundle Analyzer. It's basically a plugin for Webpack, which tells us information around what your bundle consists of. So if you just focus on the main bundle here, you'll see there's source, there's something called temp, which we can ignore for now, and there's something called routes. And below that, there's a humongous temp content routes. Notwithstanding the names, basically our idea was that this content routes will have the config file which we just generated. But as you can see, that is taking the majority of our bundle. So we did find the issue. Our bundle is basically having all the Markdown files that we have, basically bundled into one single main bundle. So this means that if you load any of the 1300 pages, you are loading all your pages in one go. So it's not an SSD system, it's not completely a CSR system, it's somewhere in between. So we were quite taken aback. We should have looked at it before, as in like anticipated this. So we're thinking, what should we do? Should we tweak our parsers so that it's client side only, and we probably move to an SSR or a CSR based system, or even an SSD system would work in that case? Should we just drop this phase? Should we just move on to phase 2? Because phase 2 has MDX, and MDX can easily help us with this. We'll go into detail why. Or just go on a long vacation till React Server components are shipped. And again, I'm very grateful because I don't have to explain React Server components. Cool. So looking at this, we thought let's just take a step back and let's analyze what is going wrong. So we know that our main bundle is bundling all our files. So how do we go about, or how do we fundamentally not bundle everything in a single bundle? And this is a question to the audience. How do we ensure that not all our files are bundled into a single bundle? Come on, you just heard a nice talk on that. Yeah, code splitting, I heard that somewhere. So yeah, so now we know we need to do code splitting. But how do we do it? That was a question in our head. Code splitting basically works for JavaScript, but our content files were empty files. So how can we possibly do code splitting here? Okay, so we thought, what if we create a component for each of these content pages? We have a JavaScript component which will contain all the content that we have. And that way, that was our aha moment. So that way we can basically do code splitting and split our bundles for each of the content pages. So that is what we ended up doing. We basically updated our automated route config generator. If you see, this was the old one where we were, if you notice, 2.2, we were reading the Markdown and we were converting it to HTML, and we were just returning that in the route object. But now we decided to take that HTML and inject that into a React component itself, and just pass the component name back in the routes config. So that way, whenever we are rendering a system, we'll just render a component instead. I'll just quickly show a little bit of code. So this was the earlier code. If you notice again, we are basically returning HTML where we have written content. Now if you check it, we are, after converting to HTML, we are basically generating a component, and from that component, we are just passing the component name into the routes config. This is how our routes file looks like now. So there's just one route right now, but imagine there are 1300 such routes. We define the path, and then we define a render function. And within that render function, we pass the component name that needs to be rendered or that particular path. And within render route, we are basically lazy loading that component. Now on lazy loading, what Webpack or any other bundler does is basically split your bundle at that point of time. So if you see here closely, all our paths are now code splitted. Okay, so what was the result? A scalable website. And that's how I felt after this. If we see the updated network bundle, we have cut down all the way from 20, okay, I actually forgot, some 20 odd MB down to 2 MB, and gzip is less than 1/10. So I know this is not the best right now, but for us, this drastic change was required for this project to even go ahead. This is our website, and if you see the updated bundle analyzer, you see those index.md bundles everywhere. Those are all our independent code, independent content. Cool. That is pretty much it. Let's just quickly have a recap. To move to for phase 1, we wanted to figure out how to render Markdown in React. So this is basically based on our constraints that we already have plugins that are built, we already have content which is written based on those plugins. We wanted to figure out what routing approach we should choose. Once we decided on those two, we went ahead with a POC, which miserably failed. So we had to figure out how to improve the issues that were there. We went back to our basics, we reconsidered what we were doing, and we finally fixed the issues that we got. Right, so after phase 1, the future holds phase 2 and phase 3. So in phase 2, we'll basically move to MDX. MDX will be a much better improvement for our parsers, given that it's based on unified. Again, that can be a whole talk on itself. But yeah, in short, it gives us a very predictable way of parsing our Markdown and converting that to HTML, and it gives a very easy way to extend the interactivity in the website, which is what phase 3 is going to be about. Yeah, that was me. Any questions?
Hi, thanks for the talk. I just have one question.
Mhm.
Like, at what point did you realize the bottlenecks of your basically documentation management that you decided to build your own website instead of using something like open source blogging tools like Ghost? Um, because like they have great API support, you can connect it directly to your database, get data from there, and yes, I understand the trade-off is that your website won't look very nice. You'll have to do the UI work still, but a lot of that data management that could have been, the heavy lifting could have been done by that open source tool. So what were the bottlenecks there?
Right, that's a very valid question, and that is a question that we also asked ourselves before moving on to our own system. So we have a lot of constraints around what kind of an existing system we already had, right? We had a lot of custom components or custom code that was already written on top of Markdown, which will not be supported by third parties very easily. Our system was based on GitHub, and we had a lot of tooling that was already there around it, right? So we didn't want to throw all of it away to move to a separate system. We did try to use something like Docusaurus, but at Docusaurus V1 was not something that was fitting our bills. Probably we can look at Docusaurus again with V2 that has quite a good feature set. But even then, I'm pretty sure that there are things that are specific to Razorpay or our system or our tooling, which required us to build our own.
Oh, thanks.
Anyone else would like to ask a question?
All right. Thank you. If you have any more questions, just reach out to me on Twitter.
Thanks, Siddhant.